Dear friends, colleagues, and fellows, welcome to HSC tutorial. Today's topic is lifting safety part 3. As you are aware of, lifting operation training series is ongoing and this is part 3. Prior to start part 3, let me give you a brief introduction about part 1 and part 2. In the lifting safety part 1, we have learned about POVA and LOLER regulations 1998. POVA stands for the Provision and Use of Work Equipment Regulation 1998, while the LOLER, the Lifting Operations and Lifting Equipment Regulation 1998. Other than the introduction of regulations, in the part 1, we have discussed the roles and responsibilities of employer, HSC department, role of management, role of supervisory staff, and the duties of employees, in addition to the short terms and definitions, those were related to lifting safety. Part 2 of lifting safety was mainly about planning, principles of lifting operations, role and responsibility of lifting appointed person, factors to consider for lift categorization, inspection, testing, and maintenance of lifting equipment and lifting accessories, types and classification of lifts as per BID standard 7121-3, and the requirements for crane operator, rigger, slinger, and lastly, how to carry out safe lifting operation, the working strategies. I'm your host, Javed, and you are watching Safety First. As usual, if you are new on this channel, kindly subscribe the channel. And if you find the video informative, then like and share. Let us start lifting safety part 3. This is related to operational planning. Dear friends and fellows, an essential part for any lifting plan is risk assessment. While preparing a risk assessment for lifting, you have to consider the following factors: cultural, communication, and language difficulties, weight, size, shape, and center of gravity of the load, availability of approved lifting points on load, method of slinging, attaching or detaching the load, overturning, load integrity, and need for taglines, suitability and condition of lifting equipment, initial and final load positions, and how it will get there, ground and underground considerations, lifting over live equipment, number and duration of lifts, conflicting tasks in the area, in the work location, environmental conditions, including weather, lighting in the pickup and lay down areas of the load, proximity hazards, obstructions, path of load, for example, potentially live electrical, hydraulic or pneumatic lines, underground conduits, bridges and overhead structures, etc. Working under suspended loads, access and emergency escape routes for the lifting appliance operator and load handlers, banksman, slinger, experience, competence and training of personnel, number of personnel required for tasks, pre-use inspection of equipment by operator, visibility of the load at all times by either the lifting equipment operator or the person guiding the load, banksman. He must maintain communication with the operator at all times, either via hand signals, radio, or the similar other means of communication. What are the common hazards during a lifting operation? Weather conditions, wind conditions, unsafe equipment, defective components of the equipment, or lifting accessories, and live electrical contact. These are the most common hazards anyone can face during the lifting operation. Have a look in the photograph. The person under the suspended load, outrigger without tent. Dear friends and fellows, you have to consider the common hazards. Machine weight and vibration can cause excavation to collapse and overturning of the crane if the crane is parked and lifting operation is ongoing adjacent or near the unprotected edge of the excavation. If the crane is parked, sewers and water mains can collapse from machine weight and vibration during lifting operation. So once you are going to start the lifting operation, you have to make a thorough inspection and understand the condition of the ground. What are the proximity hazards? At any place where a crane or its load passes an obstacle, the following apply. Where practicable, the crane path should be clearly defined by marking to ensure that it is kept free from obstruction. And a clearance of not less than 600 mm should be arranged between any part of the crane and any obstacle. Where goods are regularly stacked near a crane, boundary lines for the stacking of goods should be permanently marked on the ground. Whenever you are going to start lifting operation, you have to consider these proximity hazards. Another major cause of crane accidents are power lines. Crane contact with power lines is a major cause of serious injuries and fatalities involving those working with crane. Before any work has begun on a job site containing power lines, the person responsible for operation must contact the utility company or the service provider. It may be possible for the power lines to be temporarily diverted around the job site or de-energized and visibly grounded, or for insulating barriers to be erected to prevent contact between the crane, load, and the power lines. However, if none of these options are feasible, the following procedures must be observed. An on-site meeting must be held between the person responsible for the job, the owner of the power lines, or a designated representative of the electrical utility, the operator, and all personnel involved in the lift, including any signal persons, riggers, slingers, lifting appointed person, lifting supervisor, crane coordinator, etc., to establish procedures to be followed. You have to maintain safe distance from the electrical lines. You have to follow this table once you are going to start lifting operation and once there is no other way to divert or to de-energize the electrical lines. Once the operation near high voltage lines up to 50 kilowatt, you have to maintain 10 feet distance. Once the power line is in between 50 to 200 kilowatt, you have to maintain 15 feet. Once the power lines are in between 200 to 350 kilowatt, you have to maintain 20 feet distance from the power lines. Once the power lines are in between 350 to 500, you have to maintain the distance of 25 feet. Once the power lines are 500 to 750, you have to maintain the distance of 35 feet. And once power lines are over 750, you have to maintain the distance of 45 feet or 13.72 meters. But remember, environmental conditions such as fog, smoke, or precipitation may require increased clearances or distance. Now we are going to discuss crane standing or supporting conditions. In other words, the ground conditions where the crane is parked to carry out a lifting operation. Cranes can be fitted with outriggers or stabilizers to enhance stability and to significantly increase lifting duties. For that reason, ground should be strong enough to withstand maximum outrigger pressure. Dear friends and fellows, let us discuss safe system of work, method of statement related to lifting safety. A safe system of work is a formal procedure based on a systematic examination of work in order to identify the hazard. It defines safe methods of working which eliminate those hazards or minimize the risks associated with them. Let us understand the process of preparing safe system of work. There are 5 steps. Step number 1, assess the task. Step number 2, identify the hazard. Step number 3, define safe system of work. Step number 4, implement. And step number 5, monitor. When developing a safe system of work, once you are going to develop a safe system of work, don't forget 4 important factors: people, equipment, materials, and environment. Let us discuss one by one. Factor number 1 is people or person, their safe behavior, competency, experience, and the skills of the individuals. In the equipment, safe installation, also the ergonomic factors and location of the machines or equipment. In the materials, what materials will be used, what are the hazards of that particular material. In the environment section, you have to consider in what type of environment will the work will take place: lighting, availability of space, wind, ground condition, or temperature, etc. In the presence of any of these factors, it may increase the level of risk, and it is your responsibility to control these risks to an acceptable level. Dear friends and fellows, let us discuss the lifting plan. Do you know what are the parts or the important elements of a critical lifting plan? Before making a critical lift plan prepared by a qualified person, such as the lifting appointed person or the lift supervisor, in consultation with the riggers and the crane operator, should be considered. The lift plan should be documented in writing and made available to all personnel involved in the lift. The critical lift plan often includes the following information: description of the lift, crane position and configuration, height of the lift, load radius, boom length and angle, size and weight of the load, percent of crane's rated capacity, personnel involved with clear role, responsibility, accountability, and authority, rigging or slinging plane, communication method, ground conditions, environmental conditions, inspection procedures, procedures for hoisting personnel if applicable, and task risk assessment. The critical lift plan should document all pertinent information like load weight, crane and rigging capacities, inspections of wind speed, etc., and should include an approval sign off provision. The critical lift plan should be based on the operational limitations specified by the crane manufacturer's load chart. Measured load weights as opposed to calculated load weights should be used when available. Lifting of material and lifting of person. There is a huge difference between both the activities, although in general both are the lifting operations. Let us look what lifting equipment is required for lifting persons. The need to use lifting equipment to transfer or lift people should be assessed on every occasion. Ideally, The lifting of personnel should be eliminated as far as possible. If, after assessment, there is no alternative, the equipment used needs to be specifically designed or adopted for that purpose and operated within its design parameters. You have to use man lift basket that should be certified and load tested, and certification must be valid, and the last inspection shall be in the duration of 6 months. For safe lifting operation, no one can deny the effective means of communication. Failures in communications are often root causes of lifting incidents and can also be the most difficult to detect. Good training and adherence to correct procedures are vital, but checking the actual situation at the work site is of utmost importance. For example, are the personnel concerned all from the same company? Do they all understand a common language? If not, is there an established system of signals in strict use that they all know and understand? Is it displayed where the lift team will be able to see it? What different methods of communication are able to be used? What communication is required between the worksite and the source of any technical assistance elsewhere? If a signal is not clear to a member of the lift team operating any lifting equipment, then the operation should be stopped. Any person should be able to stop the lifting operation whenever there is a potential safety issue leading to consideration of a management of change procedure. This may occur because of any potential safety issue. For example, a signal is not clear, an alarm sounding, for example, in the operator cabin through the control panels, or specific competence exceeded. These are the few conditions where someone can stop the job. Someone can stop the lifting operation till the corrective action, after the risk assessment, after preparing the lifting plan, after inspecting the ground and proximity hazards prior to start the lifting operation. Toolbox talk or a safety meeting between the lifting team is mandatory. The lifting in charge will conduct a toolbox talk meeting and will explain the objective of the job, plans and methods, responsibilities of different individuals. Those are the part of lifting team. Manpower and skills, how many, access and evacuation, work environment, hazards, permit to work system, PPE, personal protective equipment, materials, isolation procedure, conflicting activities, information, motivation, means of communications, and debrief on post-job talk. He has to clarify what is the intention, how is it to be done, who does what skills are needed, can we get in and out safely, is it a safe work area, risk assessment, obtain documented authority, what PPE is required, what equipment are required, what materials required, safety barriers deployed, what else is going on and what else is needed. Alert anyone who could be affected, why the task is necessary, how to establish communication. And he will also explain, if he is going to brief some past incident, that what was good there and what was bad and what lesson we have to learn to avoid the similar incident while we are going to start the lifting operation in our workplace. These all questions and answers should be clear in the toolbox talk meeting by the lifting in charge or lifting appointed person or the lifting supervisor to all those are involved in the lifting operation. There are some general rules. Everyone who is involved in the lifting operation, either he is a safety professional or the part of lifting team, must check the load rating. It is mentioned on the block and the hook and on the boom and on the superstructure of the crane. Always ensure the lifting device and all supporting components are rated for the load to be lifted. For example, you cannot lift 10-ton load if the maximum or the rated capacity of lifting is 5 ton. Never allow a co-worker between a fixed object and a load. It can cause crushing. Always think before you are going to lift. Always position lifting device directly over load before lifting. Dragging of the load is not allowed with the crane at any cost. Always ensure that you know the safe travel radius of the crane. Contact with electrical sources or other hazards can result in catastrophic consequences. Always ensure energy sources are dissipated before initiating any maintenance activity. In that case, you have to adopt the principle of lockout tagout. Now, we are going to start lifting, but prior to start lifting operation, let us discuss the lifting factors at the final stage: size, weight, and center of gravity of the load, the number of sling legs, the angle the sling makes with the horizontal line, the rated capacity of the sling, and the history of the care and usage of the sling. Because for lifting equipment need a lifting accessory or lifting tackle or lifting gear that is attached with the load. Crane cannot lift the load unless there is no attachment of load with the crane hook. For that reason, you need lifting accessories, lifting gear, or lifting tackles. To make a level lift, the crane hook must be directly above the center of the gravity point. If the crane hook is too far to one side of the center of gravity, dangerous tilting and unequal stress to the sling leg will result. Dear friends and fellows, you are watching Safety First. At the moment, we are considering lifting factors. Let us discuss how the number of legs and angle with the horizontal will affect the load of the sling. As the angle formed by the sling leg and the horizontal line decreases, the rated capacity of the sling also decreases. The rated capacity varies depending upon the type of the sling, the size of the sling, and the type of the hitch. Consult with the manufacturer. Also, older slings must be used with additional caution. Sling charts are generally based on new sling usage. But never forget, mishandling and misuse of sling are the leading cause of sling-related accident. Proper care is essential for maximum service and safety. Always protect slings with the cover saddles or wood blocking to prevent sharp bends and cutting edges. These are the precautions to protect slings from cut or damage. While estimating weight of the load, you can use a dynamometer. You can check the shipping papers, check nomenclature plates, use industry standard tables or charts, consult with the equipment manufacturer, estimate weight using weights of similar loads. Never attempt a load lift based solely on a guess or your own estimate. Stay within 50% of the crane's rated capacity when estimating loads or manufacturer recommendation. Dear friends and fellows, as I told you, for lifting load with the crane, rigging or slinging arrangement is mandatory. Without slings, a load cannot be lifted. Let us discuss the types of rigging and slinging arrangements of material. Mainly these are chain slings, wire rope slings, fiber rope slings, and synthetic web slings. But remember, each type of sling has advantages and disadvantages. You have to consult with the sling manufacturer concerning load capacities, usage methods, restrictions, limitations, and other pertinent data for specific type of slings. Here are a few generic rules you have to remember while using slings. Never load in excess of the rated capacity. Never use a sling that is damaged in any way. Never pull a sling from a suspended load under tension. Never shorten with knots, bolts, or other makeshift devices. Always keep suspended loads clear of employees. Always keep suspended loads clear of all obstructions. Always keep hands and fingers clear of untensioned loads. Always pad or protect slings from sharp edges of the load. And always think before you effect a load. Do you know the inspection procedures for a wire rope sling? You have to remove from service if you find number one, 10 randomly distributed broken wires in one lay. Number two, 5 broken wires in one strand in one lay. Number three, kinking, crushing, bird caging, or any other damage. Number four, evidence of heat damage. Any end attachments cracked, deformed, or worn. And number six, hooks that have been opened more than 15% of the normal throat opening are twisted more than 10% from the plane of the unbent hook. Do you know the inspection procedure for alloy steel chain slings? You have to remove from service if you find number one, defective or questionable welds. Number two, bending or elongation of chain links. Number three, cracked or deformed master and coupling links. Number four, missing or removed identification tags. Number five, any end attachments cracked, deformed, or worn. And number six, any other reason to suspect an unsafe condition. Dear friends and fellows, do you know the inspection procedures for synthetic web slings? You have to remove from service if you find number one, acid or caustic burns. Number two, age deterioration, drying out, cracking, etc. Number three, melting or charring of the sling surface. Number four, snag, tears or cuts causing exposure of colored thread. Number five, missing or removed identification tags. And number six, any other reason to suspect an unsafe condition. Once you carry out a lifting operation, you use the sling safely. After the end of the lift, you have to clean the sling, check for damage, follow proper storage rules, leave in proper condition for the next lift. Don't wait to report damaged or defective sling, and follow proper disposal or replacement procedure if the sling or the webbing is no more usable or it can lead to a potential lifting accident. Do you know the storage rules for slings? Always store slings in a dry environment out of direct sunlight, off of the floor or ground to prevent corrosion, hung from hooks to prevent tangling and easy access, away from electrical sources. By type, don't mix steel chain slings with synthetic, and you have to keep or store the slings in a controlled area, in a secure area, where there is access for only authorized personnel. Dear friends and fellows, if you are interested to learn in depth about the sling safety, then you have to click on the link that is appearing on your screen now. Dear friends and fellows, do you know the difference between inspection and thorough examination? Either it is for lifting equipment or lifting accessories or lifting tackles. Inspections may be carried out by personnel with sufficient experience and competence to do so as specified in company procedures. For example, inspection can be made by lifting supervisor, lifting appointed person, and HSC officer or HSC inspector. But the thorough examinations and the marking of equipment are carried out by the independent competent person, mostly by a third party that must be accredited by a competent authority. And that's it. Training session related to lifting safety or safe lifting operation part 3 is over now. Today we were discussing about the operational planning. Hopefully in the next video part 4 we will learn about different loads and load calculations. That session will also be very important. In the meanwhile, if you have any question related to part 3 of lifting safety, please ask in the comment section. Thanks for watching and don't forget to like, comment and share the video. Hope to see you soon with a new HSC tutorial. Till then, take care, good luck and Allah Hafiz.